Hello everybody. Today we will discuss about the strength or brightness of an echo in an image, which depends on three factors: amplitude, power, and intensity of a sound wave. We have already studied that as a sound wave travels through a medium, the particles of the medium vibrate back and forth about their fixed positions. The greater the amplitude of the wave, the further these particles are displaced from their usual resting position. This displacement reflects the energy carried by the wave. In summary, amplitude represents the strength or amount of energy a sound wave carries. In ultrasound imaging, amplitude also relates to the brightness of the echo displayed on the screen. A stronger echo resulting from a higher amplitude appears brighter on the ultrasound image. This helps clinicians to interpret the strength and characteristics of the structures being imaged. A high amplitude wave carries a large amount of energy. A low amplitude wave carries a small amount of energy. The amplitude of the returning waves determines the brightness of the pixel assigned to the reflector in an ultrasound image. The brightness of echo is directly proportional to the amplitude of the sound. The greater the amplitude of the returning wave, the brighter the pixel assigned. Power is a measure of how quickly work is done, or how quickly energy is transferred. It tells us how fast something is using or producing energy. Imagine work as the amount of energy that is transferred, or more simply we can say work is equal to the amount of energy either you give to something or you take away from something. Power is like asking, how quickly did you do that work? Example, let's say we have two weightlifters lifting the same weight. They both are doing the same amount of work because they're lifting the same weight to the same height. However, one lifter lifts the weight faster, let's say in 1 second, while the other lifter takes longer, say for example 3 seconds. The one who lifted the weight faster would have a higher power output. Regarding unit of power, it is typically measured in watts, which are joules per second. It tells us how many joules of energy are used or produced every second. In summary, power is all about how fast work is being done or energy is being transferred. It's like asking how quickly something is using or producing energy. It is calculated by dividing the amount of work done by the time it takes to do that work. Intensity refers to the concentration or amount of energy present in a sound beam. It tells us how much power is distributed over the area of the beam. Intensity is calculated by dividing the power of the sound beam by the cross-sectional area of the beam. So, if you have a certain amount of power spread out over a larger area, the intensity will be lower. Conversely, if the same amount of power is concentrated over a smaller area, the intensity will be higher. Intensity depends on both the power in the beam, that is how much energy it carries, and the cross-sectional area of the beam, that is the area over which the power is distributed. Think of intensity like focusing a flashlight beam. When you concentrate the light into a smaller area, it appears brighter because the same amount of light is spread out over a smaller space. Talking about unit of intensity, it is typically measured in units of watts per square centimeter or milliwatts per square centimeter. This tells us how much power is being applied over a specific area. Watts from power and cm from beam area. In ultrasound imaging, intensity, like power and amplitude, plays a crucial role in determining the strength of the sound waves and the brightness of the echoes produced. It's like adjusting the volume of a speaker dash. Higher intensity means stronger waves and brighter echoes. Intensity can vary depending on the type of ultrasound technique used. For example, in grayscale imaging, the intensity is lower compared to color Doppler imaging, where more power is needed to detect blood flow. Pulse Doppler, which measures blood flow velocity, typically has the highest intensity. In summary, intensity describes the concentration or amount of energy present in a sound beam. It depends on both the power of the beam and the area over which the power is distributed. Understanding intensity helps in controlling the strength of ultrasound waves and interpreting the resulting echoes in medical imaging.